Hello. Um, where I needed to make this video to try to clarify a concept that I'm talking about in a recent blog post. It's about when we're designing handlebars and integrated handlebars, where do we reference when we're trying to describe it, right? Now, for until recently, or just now, I should say, I've largely been using the end of the handlebar to describe the location, in a way, of the beginning of the sweep. So we have our width and we have a specific point from the crank axis, right? So from here up to here, we have a line, and that's our radius of the hand grip radius, I call it. And then we have the hand grip angle, which from horizon is describing the angle. So we have an angle and a radius. Generally, that radius stays fairly constant, depending regarding different bikes in terms of like, is it a short travel or a long travel bike or something like that, or full rigid off-road bike. Let's say we're in the same kind of riding conditions like mountain biking, whether it's a full rigid or a bigger bike. What's going to change is the angle, not so much the radius. The radius is kind of like your comfort zone in terms of holding on between your feet and your hands, right? And so we're going to change the angle depending on what we're optimizing for, whether it's raw downhill speed, a mix of both, or full race, right? XC style or something like that. We're generally going to change the angle of that. Now, up until now, like as I've said, I've used the end of the hand grip here. Well, that kind of was better than anything else we had previously. But as I've said before, that's got a problem. When we start changing our sweep angle or our roll angle with respect to the bike, effectively the angle to the horizontal here, that there is going to be the roll angle because we're rolling about an axis effectively. And the sweep is like this, the back sweep, right? We've got a slight angle to the bars. Now, if you look at commodity handlebars, this is a fairly good cross section of what's out there or something. Up top, we've got some race faces at about 9 degrees for sweep, right? So that sweep angle is common in commodity land. And this white bar that I described here, it goes up to 11. That's on the higher side of a commodity handlebar. Usually they're going to be 9 or 10 degrees. Down below on this cruiser bar, we have the Surly Sunrise, which has a 16-degree sweep, which is significantly more. And you can see when we're looking at the measurements in terms of the offset right here, you know, this has a 92 millimeters to the end due to the height and the sweep and all that working together, versus one of these earlier ones is about, like, this one's 53 millimeters, this one's 46. So in a way, by going to this bar, we've moved the grips further back, I don't know, 45, 50 millimeters, 2 inches rearward, which is quite a different handlebar setup, okay? When we're designing the bike, we're correcting for this kind of thing. And it was the clunkers really that got me pushed into this. And then later when I did the Warbird, the integrated handlebars, where I had to like really figure out hand grips. Anyway, so what I did, because we can readily measure this stuff and it's easy, and in BikeCAD we can reference the ends of the hand grips now. that's what I've been doing for a long time. But there's a problem. Um, when we talk about, well, let me pull this up. I wasn't prepared there. Let's see. Where's this hand grip drawing? There we go. Let's pull up this drawing of the current handlebar assembly. Okay, and it's going to take forever. What we're changing to is, instead of the end of the bar, we're going to move 60 millimeters inboard to reference. And this is important. Now, it adds a tremendous amount of complexity in terms of understanding the setup, but it's more accurate to how the hands interact with the bar. That, the end isn't really the operative part of it. Here, I'll do this. The end of the grip can move considerably while a point somewhere in this region stays relatively consistent, let's say. Now, of course, there's a hinge here that's, getting triangulated, but, we're trying to make things better, but not insanely complicated that we can't move. But I have found about 60 millimeters from the end. Typically when I'm riding, I'm kind of like this. That's my kind of standard grip when I'm riding. And I chose about here, this knuckle area, the third metatarsal or whatever it is, as a reference. And that's about 60 millimeters from the end of the grip. So if I'm trying to keep a consistent reference in terms of fit, it's better that I'm there than here. And I'm going to show you why. Let's go to this sketch here. Okay, I took some time to draw this out. So here we have a measure of 58 degrees up, 837.5 millimeters of a radius, right? And then we define our plane, 20 degrees. This is the roll of the bars. And then we draw the sweep in two configurations. In this one, it's a 20-degree sweep, and here it's a 10-degree sweep, okay? If I just take a measure between the actual points we like to reference, we're there at about 10.46 millimeters distance, just as the crow flies. Well, that's significant. I mean, if you're on a 10 millimeter different stem, you tend to notice that kind of thing. So this is not trivial when we're talking about moving from, say, well, and this is because my current handlebars are about 20 degrees of sweep, way more than even the Surly Sunrise type of setup, which is one of the most back sweep of, say, a commonly available bar you might choose depending on the situation. Anyway, but you can get some 12s, is that right? 12-degree mountain bike bars from not Syntace, the other company. Anyway, that German company. But anyway, the point being here is that if we're taking a distance from this axis, which is the end of the handlebar, we've got a big problem here, okay? Because we didn't intend the effective body reach to change by 10 millimeters, but it did. And that's entirely dependent just on the sweep angle. So let's change this. I'm going to hide these guys, and let's go down to here. Is that right? Okay. Oh, that's a different sweep angle. Where is it? Oh. There. Oh, here we go. Sorry. This is a different setup here. Okay, so now let's look at the difference if we reference a point 60 millimeters inboard. You can see my sketch here. 60 millimeters in, and that's where these two details are crossing. And, well, it's a million times better. It's fairly consistent. I don't know why that should have been at the same exact point. Anyway. Regardless. But they're the same, but we're using a different grip offset reference here, where to get effectively the same exact situation as up here, now these two are the same. There's that sketch and that sketch. I have needed a totally different line set up with the radius and the angle to describe it because I'm choosing a different point, and I can correct for that. But what that does is it makes it so that if I'm using this one, the one that's 60 millimeters in, I'm going to get much more consistent results. Okay, it's a big difference, right? We don't want to be changing because our sweep changed. Well, that also is affected with roll. So here's a different roll angle. I chose a 30-degree rather than a 20-degree roll. And if you notice, we're going through that same point again. We're referencing that. And so now, either sweep changes or roll changes, I've basically got a consistent point, because that's how your wrist is kind of connecting to the bike. It's a feel thing, but your body doesn't end up changing positions. If I do it with the other one, the body changes positions. Yeah, so this is some tricky stuff, and when we're dealing with this fancy handlebar here that is all integrated and everything's reliant on it, I'm not going to make that twice. I'm going to make that once. And that's been the big thing with integrated bars and the stuff that I've been doing, is I have to figure out how to nail it. Okay. Now, the last bike, I believe, with the handlebars for the all-road was an 18 on the M2F2. And I went up to it was either 18 or 16. I went up to these, and I was trying to correct for that. And I did a pretty good job, but now I've changed that. And let's go to the master handlebar. Well, let's go to the handlebar assembly. There we go. So there's just the handlebars here. But of course, in here we've got our master part, and here's all of our equations type of thing. And that's the equations list for a handlebar assembly like that, trying to describe a bunch of stuff. But this stuff right at the beginning here, that's the stuff I'm showing on my website, where I'm talking about the roll and the sweep and the new position and stuff. So that's what's changed. And this is actually a big move for me. I've gotten a bunch of stuff done this weekend. Something about holidays and me taking the dive is a real thing. But it gets better. And I'm really looking forward to this kind of thing, because it was sitting there for a long time. And we're going to talk to Brent about trying to fix that. All right, so sorry I'm long-winded, but I'm long-winded. And we'll talk about